Let's look at a few examples of how to use these equations to solve problems. So let's look at our favorite ball again. Suppose that this ball is on a very smooth table and the ball has a starting velocity. See, it has a starting velocity of let's say 2 meters per second, and then it accelerates. It goes faster and faster. Okay, and after some time, okay, it increases in velocity to say 10 meters. See, 10 meters per second. Now suppose we are given, okay, suppose we know that the acceleration is actually 3 meters per second squared. 3 meters per second squared. And the question is, what is the time? Right? What is the time? Right? Given the starting velocity and the final velocity and even the acceleration, what is the time it takes to go from 2 meters per second to 10 meters per second? Now, in order to do this question, we can make use of the equations. We have already seen that there are few equations, and so we need to choose which one. Now let's just quickly review what information we have. Right, we have the initial velocity, which we usually call u. We have the final velocity, which we often call v, and we have the acceleration. And we want to find the time. So we have u, a, and v, and we want to find t. So these are the four numbers. Okay, so what we do is u, v, t, a, right? These are what we have here. Let's go back to the equations. Let's have a look. We have u, v, t, a. All right, these are the variables, the quantities involved. Now the way to do it is to look through these four equations, this 1, 2, 3, 4 equations, and find which of these contain all four of these quantities. And we do need to search through it one by one, and with practice you can do it quite quickly and even mentally. Now in this case, I will just point out straight away that this is what we are looking for. Look, you see, u, v, t, and a, right? Okay, and so we have u, v, t, and a. We have all four quantities in this first equation. So that's what we want. So this means that we should make use of the first equation. Now, having discovered that we need the first equation, we then need to work out how to use it to give us the answer. Right. The usual way is to go to the information that we have, like this one, the values we already given for u, v, and a, the acceleration, and plug these numbers into the equation and then solve for the t. So that's how one way to do it, and we have to do it by algebra. Now the way that I like to do it is to actually solve put a t before putting in the numbers. Now the reason is because if I start putting in the numbers, numbers can have more than one digits, can have a few digits, and it can start getting quite messy, lots of digits to write out. So let me try that. What I now want to do is I want to take this equation and I want to make t the subject. So I want to rearrange it so that I have t on one side. Okay, so let's go. Let's do it. Okay, let me just reproduce the equation down here. V is equal to u plus at. I want to solve this for t. I want to make t the subject. So that means that I just want t on one side. So that's the t there, and I want to move the u away, for example. All right, so that only t remains on one side. So I could subtract u from both sides. If I subtract u from both sides, the u would disappear from there. Okay, and I would have a minus u on the left side. So now I'm one step better. I just have a times t on one side, but I really just want to have the t. I don't want the a. Now here a is multiplied by the t, and to get rid of the a, I would want to divide both sides by a. So if I divide both sides by a on the right hand side, I'll be left with t, and on the left hand side I would have the whole of the left hand side divided by a. And now I have t as the subject. I can then substitute the numbers that I know into the left hand side to find the answer. So let me write it out this way. Okay. So t start on the fine, and I want to start substituting numbers into here, right? So let's try that. Okay. I'm going to have u minus v. So v minus u. Okay, let's look for v, right? That's v, that's u. So v minus u would be 10 minus 2. Now, but let's hold on for a second. You must not forget that u and v are velocities. So in order to do this properly, I really need to choose a direction to be the positive direction, left to right. Now, I'm going to choose the right hand side to be the positive direction. You can equally well choose the left hand side. It will lead to the same answer in the end. So that's going to be the positive, and the left hand side is going to be the negative. Okay? Alright. So therefore, I need signs in front of the v and u. So v would be plus 10 and u would be minus would be plus 2, since both are moving to the right, to the positive direction. So okay, so these two are correct. They both have positive signs, and then I need to divide by a. Alright, and I know that a is 3 meters per second squared. Let me put in the a, so a is equal to 3. Okay. Alright, and I can now find the answer. The answer is 10 minus 2 is 8, so 8 over 3. And that's it, that's the answer, and the answer is in seconds. There we are. So that's how that's one example of using the acceleration equations that we have found earlier. Okay, and it's a fairly simple one using the first equation. And you can use all the rest in the same way. Just check out the quantities that you're given or that are involved, and just search through the 4 equations to see which one contain all of those information.